Okay, so number 10 on the PowerPoint is right here. It says the crankshaft converts the reciprocal up and down motion of the pistons into rotary or turning motion. This rotary motion is transferred to the wheels and eventually to the transmission or driveline. Since the crankshaft must transmit all of the power produced by the engine, it's the engine's strongest part. Okay, so on the engine, right here, on the bottom side of the engine, you can see here, this is the crankshaft. And connected to the crankshaft are the connecting rods. So, crankshaft, connecting rods, and on the end of the connecting rods are the pistons. So if you come around here on the other side, you can see that here's the pistons. If I turn the crankshaft, I can see those pistons move up and down. So as I turn this crankshaft, those pistons are moving up and down, right? But if I go to the other side, I can look and see that the crankshaft is how that happens. It's almost like a bicycle crank. So basically, when you crank your bicycle pedals, it's going in a circle motion, and this is the same idea for the pistons to move. Okay, so how this works is when we have our cylinder head on here, we allow air to come in and come into the intake, and then it goes out through the exhaust, and we create combustion. So basically we're making a little explosion, and we time it on each one of these, that when that piston, like this piston here, is ready to go down, as it's almost ready to go down like that, we make a little explosion right there, and that pushes on that piston really hard. And so then that pressure pushes that piston down, and that causes the crankshaft to come down too and spin. Okay, so it brings it all the way to the bottom. Then the next piston that's ready over here, and that will change, that one gets a same thing. It gets an explosion, ignition, or combustion, whichever. It depends on diesel or gas, but basically it makes an explosion right there, and that one pushes down. So in turn, that one over here makes that crankshaft spin again. And so what we have is this is a V8, so I have 8 cylinders pushing all at their own time, taking turns, spinning that crankshaft all the way around. And so that crankshaft will spin and spin and spin. Well, on the back side of the crankshaft, right here, is where we bolt our flywheel or our torque, our flex plate, so our torque converter, or we hook this to the transmission. However we're going to do it, to take that spinning motion, that force, and put it out to the rear wheels, so that the rear wheels will spin and we can move forward, and then we can also change it to reverse by changing the gears. And so if the gear spins one direction, we can put gears together a certain way in the transmission that will cause it to go in reverse as well. But the engine always spins the same direction. If it's a clockwise or counterclockwise engine, the engine will always spin whatever direction it's supposed to spin, okay? How it's designed. And that is basics. There's a ton more to it than that, but that's some basics. On number 11, the crankshaft protrudes through the cylinder block at the front and the rear of the engine. Oil seals are used at these points to prevent the oil inside the block from escaping. Okay, so we have a seal right here on the front of the crankshaft that will prevent the oil from coming out of as this spins. It can spin and still not leak oil. Same thing on the back. There's a big seal that goes on the back side of this crankshaft right here, and this is called a rear main seal on the back, and this is called a front crank pulley seal, or the front crank seal on the engine. And those leak a lot. They end up having to be replaced quite often. So